Okay, welcome Science 10s to the beginning of our course. We're going to start with Unit A, which is going to be looking at chemistry. So to start the unit, we're going to look at what's the difference between getting heat from burning natural gas and from heating up a stovetop element. Also looking at what's the difference between getting a burn from an acid and a burn from boiling water. They seem kind of like the same thing, but there's a big difference going on. Okay, so we're going to look at physical and chemical properties, but I think first it's good to talk about what is a chemical, because a chemical gets kind of talked about, it's kind of in your food or in our fuels or in the atmosphere, and there's often a bad association with the word chemicals. So what a chemical is it's made of protons, neutrons, and electrons, which we'll talk about a little bit later, but pretty much a chemical is anything on the periodic table or anything that has mass. This is pretty much everything that you come into contact with. The food that you eat has chemicals, the air you breathe is made of chemicals, you yourself are made of chemicals. And some of these are harmful, but some of them are also really, really good. So I think it's important first to note that I think there's this kind of association with chemicals as being dangerous and terrible for you. And even chemical names can seem scary. If we said you're gonna drink dihydrogen monoxide, that sounds like it was probably a bad idea, but that's just the chemical name for water, a very safe chemical for you. But what makes a chemical either good or bad or how it's going to affect you is based off its physical and chemical properties of that chemical. So we'll start with physical properties. Physical properties are like what the chemical is like on its own. This could be things like what state it's in, solid, liquid, or gas, its color, if it's bendable like a metal or if it's brittle, and its hardness if it's going to break apart or not. So some physical properties for an ice cube might be that it's in a solid state, at least at the time until it melts. It's transparent. If we look at metal, that's also a solid and it can be bendable, as we see this pipe is bent. And chemical properties are how that chemical is going to interact with other chemicals and what chemical reactions usually it'll undergo. So if it's something's flammable, that would be a chemical property. If it's corrosive, if it's an acid, these would be examples of its chemical properties because it's interacting with other chemicals when those things happen. So you've probably all seen warnings of things that might be flammable. There's lots of household products that would be flammable, or if they're going to be explosive or something like that, that's how they're interacting with other chemicals. Next, we're going to look at the difference between physical and chemical change. If you physically change something, you change its physical properties, but it's still going to be the same chemical. So this could be if you break it into two parts, if you bend it to a different position, if you melt it or evaporate it, it's still the same chemical, it'd just be in a different state, which we said was a physical property. A chemical change is when you actually change the chemicals that something is made of. So all that really involves, I mentioned before, it's made of protons, neutrons, and electrons. It's just changing the arrangement of that or getting more or less of any of those particles. But then it becomes a different chemical if it has a different number of those or a different rearrangement. So it's actually creating a different chemical. So I know a lot's going to pop up here. A new chemical is going to be formed, so a new rearrangement of those smaller chemicals. Now, we want to know how to identify a chemical change versus just a physical change. So I put a lot here, and can I go through them? The biggest one or most important is an energy change. Anytime you have a chemical change, energy is either going to be absorbed, and that material will be cold because it's absorbing energy, or it's going to release energy, which is going to be hot. But there's always going to be a change in energy when there is a chemical change. Other evidence that is good to be aware of is if there's a gas produced, that often indicates there could be a chemical reaction. That's not to say you can't produce a gas, like if you boil water, you're producing like water vapor, but that's just a physical change. So it's not 100% all the time, but it's a good indication there could be a chemical change going on. Same with something called a precipitate. So this is when you get a solid, but it's not just when something becomes solid, it has to be a special case where you pour two liquids together and you get a solid as a product. So that one's often people just say, oh, it forms a solid, it's precipitate, but it has to come from putting two non-solids together and your product is a solid because you made a new chemical that is solid at that temperature. Another piece of evidence, if it changes color, that could be a chemical change. Not always, but it's another piece of evidence that could indicate there could be a chemical change. And one thing to just kind of check mentally, I think, is if it's difficult to reverse, this is a good check if it's chemical or not. So imagine that you melt an ice cube. Could you easily reverse that back into ice? Yeah, you just cool it down and it's going to freeze back. So that's a physical change. But if you say burn a candle, is it easy to take the smoke and turn it back into a candle? That's not really very easy to do. So that's a chemical change. Now that we know some properties, we're going to talk about chemical safety. So why should we be cautious around chemicals if at the start I said everything is a chemical? Well, there's really three things that can be dangerous about a chemical. So 3 dangers of chemical. The first one is that I said energy is going to change whenever you have a chemical reaction, and that energy change can harm you. If you have a lot of energy being released with like a fire or explosion, that can harm us. So the energy release can be harmful. Sometimes if it was absorbing a lot of energy, that could be harmful as well, but I think it's more common that explosions and things like that are harmful. Chemicals disrupt your body function. A good example of this is carbon monoxide. That's not like blowing up or anything, but if you breathe it in, it disrupts how your body's going to use oxygen, and then causes you not to be able to use oxygen, and you can suffocate from that. So it's going to disrupt some essential life functions, and that's not good for chemicals. And the last one is the chemical can actually react with you. We are made of chemicals, so acids that usually react with something will react with your chemicals as well and cause a chemical burn. And when we have a chemical reaction, it creates new chemicals. So it's turning your chemicals into something else, which is not good for you. So we want to avoid you reacting with any chemicals that are highly reactive. So there are some systems in place to properly label and give information about the dangers of chemicals. We're first going to look at WHMIS, which stands for Workplace Hazardous Materials Information System. This is what workplaces use to properly identify the dangers of chemicals that they order for whatever work they're going to be doing to keep their workers safe. And so their purpose is to ensure that workplaces have standard information on the product and procedures for how to handle those chemicals. So they're involved in hazard identification, product classification, storage, and labeling is a really big one that we're going to look at, and training and education. Often if you're at a job where they're using some harmful chemicals, you'll undergo WHMIS training. These are the WHMIS symbols here. They were updated a couple of years ago to these ones, and so we're going to go through what each of those mean. It's kind of a long description, but I'll try and summarize it. So if you look at this chart, you can even pause the video and read through the more detailed description. I'm just going to try to summarize up what those mean. So the first one at the top here has a picture of a flame. That means flammable, and you should keep it away from any sources of heat or flame. The next one that looks like a flame but has an O in the middle is oxidizing. So that's, you talk about oxidization reactions a bit more in later high school courses, but you can think of it as being quite reactive. The next one, this container, means compressed gas. So you also want to keep that away from heat and try not to drop it or have any punctures to that container. The next one is probably kind of familiar. It's a common symbol, corrosive. Keep away from your skin, your eyes, mouth, inhalation, and also keep it away from metals that it might react with. The next one with an exploding kind of circle there is explosive. Again, keep away from heat or flame and handle with care. You don't want it to be dropped or punctured as well. Flipping over to the other side, we see the skull and crossbones. This means harmful or fatal. So this is the most kind of serious poisonous symbol on here. The next three all have to do kind of with being poisonous or harmful to us. This one's the most serious, and it says death could come from even small exposure. So you don't have to have a really large amount of this chemical or a long exposure to it to be in some trouble. So it's very short amount of time, and it's a pretty serious label. The next one with this kind of like exploding chest, which also doesn't look good, is health hazard. So it says there's serious health effects from localized area to disease such as cancer, meaning that it could affect a localized area or it could spread further throughout the body. The exclamation mark also means harmful. It just says harmful, doesn't have that fatal part of the skull and crossbones. And this means when it affects more just like an acute or a specific area. So not quite as bad as the skull and crossbones, but still can have significant damage to one area of your body. The next one with kind of these overlapping circles means biohazardous. So this means it could be infectious material, like something that could cause disease in either an animal or humans. A good example of that would be if you had something like a virus that you were studying, and you would label that with biohazardous infectious because someone could get infected from that chemical or from that material. And the last one with the dead tree and a fish means environmental hazard, and it just kind of says that you have to dispose of that, not just by putting it down the drain or throwing it out normally. There's going to be some specific ways that you need to dispose of it so it doesn't harm the environment. The next system we're going to look at is HHPS, which is Hazardous Household Product Symbols. These are the ones that you wouldn't see in a workplace. Well, you could see it in a workplace, but more commonly you're going to see them on products that you would buy for your home. So things like drain cleaners and mostly different types of cleaners. So I'm just going to go through the 4 here. It's a little bit simpler than the WHMIS. First one they have is for poison. It means it could cause illness or death when you get it inside of your body. A symbol is a skull and crossbones, the same as we saw from the WHMIS. And I just put in a chart here what you're supposed to do around those chemicals. Don't ingest or breathe it in. If you do get some of it inside your body, you should be calling poison control or 911 immediately. The next one's flammable. We saw that also in WHMIS as well. It means it will easily catch on fire. It's a very similar symbol with the flame. Keep away from any heat sparks or anything like that. Store in a cool place and have a fire extinguisher nearby if you're using it. Explosive, again, similar to the WHMIS. If heated or punctured, it may explode, sending the container flying, which is bad. You don't want to get hit by shards of the container and it explodes. The symbol is really similar to the WHMIS one again. It looks like an exploding circle. So keep in a cool place away from heat or sparks and don't drop or shake it so it doesn't get punctured. And the last one, corrosive. You notice all these are similar to the WHMIS. It's just a simpler system. May cause damage to the body. This doesn't have to necessarily go inside your body like poisonous did. It can cause damage to the outside, like your skin, eyes, or throat. It can still cause damage on the inside, but saying mostly be precautious of like spilling on your hands or getting in your eyes or anything like that, but don't inhale or drink it either. The symbol looks like this. It shows a hand going into this material and pretty much getting eaten away or corroded. So don't want to be having that on our skin. Keep away from skin, eyes, and mouth. Do not inhale. If contact, wash with plenty of water. If it does get inside your body, very similar to the poisonous one, call poison control or 911 immediately. And the other thing you might have noticed about those symbols is they had different borders. So I put up this chart to show that we do have those 4 different symbols up here at the top, but then ranking their severity is down here. So if it's got the red octagon, it's going to be the most dangerous. Warning is going to be the orange kind of diamond shape there, and then the triangle is going to be the yellow triangle is going to be for caution or the least amount of danger, but still should be handled with care. Lastly, just to finish off, I'm going to talk about MSDS sheets. So this stands for Material Safety Data Sheet. It's often when if you buy a chemical that could be harmful, instead of trying to put all the information on the label, they give you an MSDS sheet. This is usually involved with WHMIS symbols as well. So it gives you just a lot more information on the product than that you could just put in a symbol or on the actual container. So it comes with this sheet and you can look up all sorts of chemical properties, all the hazards of it, where it should be stored, and emergency procedures. Here's an example one on the side. It's going to give you the formula for what the chemical is, as we can see there. This is isopropanol, so it shows the chemical name there. It shows your kind of appearance, what it's commonly called, rubbing alcohol right there, melting point, boiling point, vapor pressure, all the specifics about that chemical. If we're to go further into this document, more things about what you should do if you spilled it, if you got it in your eye, and where you should store it, and just all sorts of information like that. Okay, so that's our first lesson in looking at physical and chemical properties, really seeing what chemicals are and how we determine if they're going to be dangerous. Make sure you take some notes on that. Ask me any questions that you have when we're in the lecture, and I will see you in the next video.